Last unit of this chapter is very similar to exponential functions that we've been talking about, but now we're going to talk about sequences. So we have geometric sequences and arithmetic sequences. So we'll get to that in a minute. Very quickly, try to figure out the answers to these. If you need help with these when you get to class, then we can do that. But for right now, I want you to come up with the equation and then solve each of these. So pause your video and do these. And there's your check to make sure you know how to do these. Again, ask questions in class if you need help. So we're going to talk about geometric sequences. And a geometric sequence is something where you have things that are multiplied. For example, in the words up there, it says 1, 5, 25, 125 is a geometric sequence. Well, why is it a geometric sequence? Well, because if I multiply times 5, I get from one number to the next. Always multiplying by 5. And this number right here, this times 5, is called the common ratio. And that's how we tell a geometric sequence from an arithmetic. So arithmetic is what we've talked about with linear equations, arithmetic. An arithmetic sequence would be like 1, 4, 7, 10. So to get from one number to the next, instead of multiplying, I'm going to add 3 on this one. And then we draw these dot dot dots to show that it continues. With arithmetic sequences, we've talked about if we have this as a chart, 1, 2, 3, and then 1, 4, 7, 10, etc. We've talked about slope because we add 3 to get from one term to the other here, and add 1 there, so your slope is 3/1. Basically, if it's a linear equation or a linear relationship, it's a sequence. But with these sequences, we just have a sequence of numbers. We don't necessarily have an x value. Okay, so we're going to determine whether this is arithmetic, geometric, or neither. Arithmetic, again, is we're going to add or subtract. Geometric is we're going to multiply by something to get from one term to the other. So if you look at this, to get from 0 to 8, I can't really multiply 0 by anything, but I can add 8. And if we check that pattern, it holds all the way across. So this is an arithmetic because we're adding 8. Then we'll check this one. To get from 64 to 48, we need to figure out what it is that we're multiplying by or subtracting to get to that one. So 64 minus 48 is going to be, 64 minus 48 is 16. So if I do that for this next pair of numbers, this is 36 minus 48. Well, that's just 12. We're taking away 12. So this is not arithmetic. So let's try geometric. 64 to 48, we have to figure out what we're multiplying by. So to figure out what we multiply by, we're taking one of the numbers, and then you divide by the previous number. So if I take 48 and I divide it by 64, I can reduce the fraction, or I can look at it as 0.75. I'm multiplying by 3/4 or 0.75. Either one of those is great to work with. And if we check this, we're multiplying by 3/4 for this one. We're multiplying by 3/4 for this one. So this one has a a common ratio of 3/4 or 0.75. So common ratio, again, is what are we multiplying the first term, second term, all of those to get to the next term. And it also always has to go in that order. Okay, so you try these two. Make sure you can do these. Pause the video and then come back and check your work. So now that you've looked at that, do you see what the sequence is on this one? This one definitely is geometric because we're multiplying by 7 to get from one term to the next. Easy to find that. It's just 7 divided by 1 is 7. And then you just go and check to make sure that it works for every single one. Okay, this one right here, I can multiply by 2 and that holds from here to here, but as soon as I get to 4 to 14, it doesn't work. Okay, so definitely not geometric. If I add 2, I can add 2 to get from one to another, but as soon as I get here, I'm adding 12. Not arithmetic. So this one is neither. Now you have to be able to figure out the next 3 terms. You go ahead and try and figure out what the next 3 terms are of each of these 2 sequences. I bet you can figure them out. So pause the video and then come back so we can figure this out. Okay, they tell us this is a geometric sequence. So if I want to figure out what the common ratio is, or what I multiply by, I'm going to take -8 and divide by 1, and that's -8. So that should hold all the way across. I'm multiplying times -8, not decimal. And then times by -8, and then you check for this one and make sure it works. So then we use that to go and multiply this by -8. And when we do, we get the giant number of 4,096. The next number in this, I'm going to erase this stuff, is going to be -32768. So anytime you multiply by a negative common ratio, it's going to be changing everything just a little bit. Hold on, I've got to get this other number. Okay, so that's 262,144. So it's going negative, positive, negative, positive, negative. Okay, next numbers in this sequence. We're dividing by 2, but that's not your common ratio. Remember, the common ratio is the number divide by the previous. So if I'm going to use 20, it's going to be 20 divided by 40, so it's 1/2. So my common ratio here is 1/2 is what I'm multiplying by. So I'm always dividing by 2. So the next 3 numbers are 2.5, 1.25, and 0.625. So what if we have, let me do these with you. So pause the video and try these, see if you can get these. Okay, your answers on this one should have been 625, -3,125, and then 15,625. Again, your common ratio here is -5 is what you're multiplying by. This one, you're multiplying by 1/4. So, and I get that again by doing 200 divided by 800. So this is 25 over 4. 25 over 16, 25 over 64. Okay, so this is the common ratio. This is the first or the initial term. So that's helpful when we get to this. This is the general form of the equation that we can use for any geometric sequence. So why would we want this? Because if I had any of these lists up here, these sequences, and I wanted to figure out the 35th term, I don't want to have to sit and do 35 of multiplying by times of multiplying by 1/4. So we come up with a formula that makes it easier. So you've got to know what each of these things are. So let's look at this at this. If I have 1 and I'm going to multiply it by 2, I'll get 2. And multiply by 2 again, I'll get 4. Multiply by 2 again, I'll get 8, etc. Right? You have to know what the nth term of a of n means. N just represents any integer. So if I'm looking in terms of, if I have a sequence like this, the first term is 1. The second term is 2. The third term is 4. The fourth term is 8. So that 1, 2, 3, and 4, that's our n. N represents the term number. The very first one in the sequence is 1. N equals 1. Okay, and then the 1, 2, 4, and 8 is what you get out of the equation. So that's this a of n. We put that little n there because if I want to find the 12th term, then n would equal 12. And a of n, or a of 12, would represent that number is the 12th term. And then r, you already know what that is. That's the common ratio. So that's what we've been figuring out. It's the term divided by the previous one, and that gives you the common ratio. So let's try this out. We're going to write an equation for the nth term of the geometric sequence. So let me put the general form right here. A of 1. A of 1 represents the first term. So this is a of 1, a of 2, a of 3, third term. So a of 1 is the first term times the common ratio raised to the power of n minus 1. That again is on this, this formula right here. So we'll go and try this. Figure out what our a of 1 is. Well, a of 1 is just the first term, and that equals 1. So far for this equation, I know I have a 1 in there. Then I've got to figure out the r value. So the r value on this, -2, divided by the previous one is -2. So my r value is -2. Package those parentheses, and then n minus 1. So that's the general form of the equation for this. So now if I want to find the 12th term of the sequence, the n is now 12. 1 times -2 to the 12 minus 1. So a of 12 equals 1 times -2 to the 11th power, which then equals -2048. You can put that in your calculator. So it's a lot easier because you could just set up the equation and then go and find out what your 12th number is. All right, so try this one on your own. Pause the video and come back. A of 1 is the first term. R is just one of the numbers divided by the previous one. It's -4. Here's the equation. Then you change your n's to 7 because we're finding the 7th term, and you should have gotten 12,288. So this one also represents a geometric sequence. The weight is decreasing 80%. So in term 1, we have 50. In term 2, the second number in the sequence, let me go and do this. The first number in the sequence is 50. The second number in the sequence, we're reducing by 80%, so we're multiplying times 0.80. So we get 40. Multiply that times 0.80, and you get 32. So if we want to write an equation for this, even though the number of hours here is 0, we're still going to do it based off of this sequence right here. So 50 is the first number, so that's our a of 1. Our r is 0.8, so this is a of n equals 50 times 0.8 n minus 1. Because it's 80%, we have to change it to a decimal version to multiply. And then this one, you begin with 32 teams in the first round, and then you have half the teams, then you have half the teams, then you have half the teams. So you just look and see which one of these represents that. So in the first round, there's 32 teams, then there's 16, then there's 8. So A would be the answer. And there you go. Happy Chapter 7. You did all these videos. Good job.